Hey guys, welcome to my new video. If you've been searching for the step-by-step training footage for the B-1 Lancer in action, its takeoff and landing, this video will reveal to you all you need to know. Just stay tuned while I show you the B-1 Lancer in action and how it takes off and lands. You probably have a lot of imaginations on your mind when you first saw how the B-1 Lancer takes off and lands online. What an amazing bomber hero were probably your first thoughts. The B-1 Lancer is a long-range multi-mission supersonic conventional bomber which has served the United States Air Force since 1985. The aircraft is on track to continue flying at current demanding operations tempo out to 2040 and beyond, and Boeing partners with the Air Force to keep the B-1 mission ready. The B-1 Lancer blended wing body configuration, variable geometry wings, and turbofan afterburning engines combine to provide long-range maneuverability and high speed while enhancing survivability. Let's discuss further about the general operations of the B-1 Lancer before we take a look at how it takes off and lands. Number 10. B-1 Lancer General Description. The B-1 Lancer was designed to penetrate highly defended airspace, attacking targets with conventional weapons, and has been upgraded for precision-guided munitions. The aircraft is powered by 4 General Electric F101 GE102 dual-rotor afterburning turbofan engines designed to produce 15,000 pounds of non-afterburning thrust and up to 30,000 pounds of thrust with afterburner. The aircraft design incorporates a blended wing body with variable sweep wings. The primary control surface consists of a 3-section rudder, 4 spoiler panels on the upper surface of each wing, and horizontal stabilators. The pitch attitude of the aircraft is controlled by symmetrical deflection of the horizontal stabilators. Roll attitude is controlled by asymmetrical deflection of the horizontal stabilators and by deflection of the spoilers. The aircraft is equipped with a variable sweep wing which can be stopped at any angle between 15 and 67.5 degrees. However, the only wing sweep positions currently cleared for use are 15, 20, 25, 55, and 67.5 degrees. Number 9. B-1 Lancer Unique Nose Wheel Steering. The effectiveness of the nose wheel steering system was evaluated while moving to and from the runway. The purpose was to ensure that the B-1 Lancer would maintain a constant track without overtasking the pilot. To achieve this, the system must not have free play and must be predictably responsive to control inputs, starting into and rolling out of turns while maintaining the aircraft position on the taxiway centerline was easily accomplished through smooth rudder pedal inputs to steer the aircraft. There was no need for great anticipation, nor was there any lag or noticeable free play. Number 8. B-1 Lancer Airways Navigation. Once airborne, the B-1 Lancer flew nicely. Aircraft control was responsive and smooth in all axes. For an aircraft to conduct a long-range mission, it is desirable for the pilot to fly with relative ease. That is, to not have to struggle to maintain a specific parameter, such as altitude or airspeed. Over the course of a long flight, this could result in pilot fatigue or a flight violation from the Federal Aviation Administration (FAA). In order to determine the ease at which a pilot could expect to maintain a precise altitude, the aircraft was trimmed to a level flight at an airspeed of 320 knots indicated airspeed. It was difficult to maintain deviations in altitude or less than 50 feet without paying close attention to the instruments. Number 7. Takeoff. The takeoff of the B-1 Lancer is one of the most important aspects that must be taken seriously. When it comes to the takeoff of the B-1 Lancer, some considerations are put in place. Let's discuss further. A consideration in the design of many aircraft is the distance that it takes off to get airborne and the ease at which the pilot can safely achieve a desired pitch attitude while conducting a takeoff. The typical concern is not to over-rotate or put the aircraft in a higher nose-up attitude than is desired. This is to preclude stalling the aircraft or to prevent dragging the rear of the empennage, which would result in aircraft damage and potentially dangerous flying qualities as a result of damage. In the case of the B-1 Lancer, with its long airframe, this is a valid concern. The ability to capture a desired altitude on takeoff was evaluated during a single takeoff from a dry runway, with a 6-knot headwind component and 10-knot crosswind component. Following takeoff, climb performance was evaluated by performing climb from 5,000 feet mean sea level to 20,000 feet mean sea level using military power. Following the contractor recommended climb schedule of 360 knots per 0.76 Mach. The time to climb was 7 minutes and 53 seconds while the fuel burned was 5,400 pounds over a distance of 59 nautical miles. Number 6. Combat range. Fuel flow requirements from test day conditions were documented and used to construct a typical B-1 Lancer mission profile. The results show the specific range, or plainly put, the gas mileage for the B-1B for different phases of flight. Based on actual fuel usage, the B-1 Lancer can start the engines with 204,575 pounds of fuel, climb to an altitude of 20,000 feet mean sea level, and land at another NATO airfield with approximately 25,000 pounds of fuel, while traveling a total distance of 3,579 nautical miles. Certainly, there are many factors that determine the actual fuel mileage that an aircraft may achieve, such as wind, the speed at which the route is flown, and the weight of the aircraft. Combat endurance. There was no specific fuel flow data collection to document the endurance of the B-1 Lancer during this single flight. However, during that single flight, the pilot flew for a total of 6.5 hours unrefueled while conducting over an hour of low-altitude flight at transonic speeds without the use of an afterburner. In general, the B-1 Lancer can stay airborne for a long time, which begs the question, why dedicate tankers to refuel Hornet aircraft, whose effects do not measure up to that of the B-1 Lancer, when that fuel can be used to keep the most effective aircraft around longer? Number 4. Aerial refueling. Even with the B-1 Lancer's impressive unrefueled range, it is imperative that the aircraft demonstrates satisfactory flying qualities in the performance of aerial refueling. If the B-1B were to receive 45,000 pounds of fuel from an airborne tanker, its range can be extended approximately by another 1,000 nautical miles, or that fuel could be used to loiter in the target area while providing support for troops on the ground. Number 3. Level turns. The B-1B cockpit is configured much like that of a fighter in that it has a stick rather than a yoke at both the pilot and co-pilot stations. It has the capability to be maneuvered aggressively like the smaller fighter aircraft in the US military arsenal. However, due to its large size and potential heavy payloads, limits on how many load factors the aircraft is allowed to pull have been established. These were put into place primarily to extend the life of the aircraft and to prevent aircraft damage. Accordingly, it is important that the pilot be able to target and capture a desired load factor without exceeding the imposed limitations. Several level turns were performed to determine just how difficult it was to capture a desired load factor. Number 2. Flying qualities. In evaluating the B-1 Lancer, flying qualities that were most important to completing the long-range interdiction mission and can be completed during the single flight were evaluated. Due to the limited scope of the actual test flight, only 6.5 hours, not all areas were looked at. However, enough areas were evaluated to make a determination as to the suitability of the aircraft. And at number 1, landing. Regardless of the massive payload that an aircraft may have, it is of little use if landing that aircraft is hazardous. The landing characteristics of the B-1 Lancer were evaluated for this very reason. Many of the hazards associated with flying occurred during takeoff and landing. It is at this time that the aircraft is close to the ground at slower airspeeds and in the midst of changing aircraft configurations. The B-1 Lancer exhibited excellent qualities with regard to configuration changes. The small forces and stick displacements allowed the pilot to make smooth transitions while changing configurations. Once configured for final approach and landing, maintaining a constant angle of attack through maintaining a constant pitch attitude while modulating the power to control the rate of descent was nearly effortless. The B-1 Lancer was quite stable in the landing configuration, which is gear down and flaps set to full. Small longitudinal inputs were required from time to time, and once again, the aircraft was responsive and predictable. The pilot was able to make minor adjustments with precise results to pitch attitude in order to counter wind gusts and other causes of deviation. This evaluation can be directly related to the instance when an aircraft making an approach to land in inclement weather breaks out beneath the weather and has little time to get on center line prior to touchdown. Thank you for watching the video, guys. If you enjoyed this video, comment down below your thoughts, give us a like, share with your friends, and don't forget to hit the subscribe button and that notification bell to keep you updated on our next videos.